The builder pattern is a design pattern used to construct complex objects step by step, providing clarity and flexibility in the creation process. So let's say that we have a class called car, and we use this to create car objects. And we also have a manual class that is used to create car manuals for certain cars. So you can see here that a manual has a set of fields, and a car also has the same set of fields here. So you can see that a car or a manual is composed of these fields. And we can see we have the car type, and if I just go into this components folder where I've stored all of these kind of components to make up a car or manual, we can see that car type can either be sports, SUV or saloon. The dashboard can be configured to either have a rev counter or not. We have an engine class here which we could provide methods and fields for the speed, model, etc. A GPS navigator class, and also a class to represent wheels. And I've just put the diameter of the wheels in inches as a sort of example field. So we can see here in car and manual they share a lot of common fields, and currently we have 7 fields that are shared between car and manual. And also in car we have a field here which is specific to this class, so it's not relevant in the manual class. And this field is called fuel, and this sort of represents the amount of fuel that is in the car. And then in manual we also have a print method which is used to print the text or create the manual from the fields or information that has been set on the object. So let's take a look at how a client would use this solution to create cars and their corresponding manuals. So first of all, let's try to create a sports car. So we can say sports car equals new car, and this needs to come from the builder pattern. And now we have to provide the sort of configuration options for a sports car. So first of all we need to provide the type of the car, and we can use the car type enum for this. So we can say car type dot sports, and then we need to provide the number of seats. So a sports car will have 2 seats. We then need to provide is convertible, so we're going to say false. This is not a convertible sports car. We need to provide an engine, and that's everything we need there. We need to provide a dashboard, and we can provide whether this has a rev counter or not. So what I'm going to do is I'm going to type out the name of the field just so it's nice and clear and put true. Okay, so then we need a wheels object, and then we need to provide the diameter of the wheels in inches, so let's say 20 inches. And then we need a new GPS navigator, so let's provide GPS navigator. And finally, I think actually that is everything that we need to provide. Okay, so that is our sports car, and then we can also specify the amount of fuel in the sports car. So let's just say it's full, 100% filled. Okay, so then we could also create an SUV. So rather than type out all of those configuration options again, let me just copy and paste an SUV. So we have the car type SUV. So I believe this is the number of seats, so I guess it would make sense here to again provide the name of the field, and then is convertible, so we could do that. Okay, so you can see that there are a lot of configuration options that we have to provide every time we create a sports car, or a car I should say. And also I've just noticed that we don't need this or this. Okay, so let's also now create a sports car manual, and again we have to provide some configuration options, lots of configuration options, and then I'm just logging out the sports car manual print. So we print the sports car manual and log it to the console, and we can also do the same for SUV. And you can see that when we create a manual and when we create a sports car, so a sports car and a sports car manual, we're actually providing the same fields to create these things, but they are two separate objects that are not really related. Okay, they don't share a common interface because a car is different from a manual. So let's run this to see what we get. And you can see we have the two different manuals. So we have a manual for sports car here, and we have our manual for our SUV. So as you can see here, there is a large number of configuration variables that we have to pass to the constructor of car or manual when creating them. So as you saw with the example, there are a large number of configuration variables that we have to pass to the constructor every time that we create a car or car manual object. And this is pretty ugly. And also, a large number of the configuration options are not needed most of the time. For example, most cars are not convertibles, and therefore we have to just keep on providing false for all of our cars or car manuals for many of the fields. So one way of not having to specify all of the configuration options when creating a new object would be to create subclasses for each type of car or manual. So here we can see we have our original base car class, and we have some subclasses to create specific types of cars. And we also have the same thing for the manuals here to create the manuals for these cars. So the problem with this solution is that our library of subclasses is likely to grow very large as more configuration variables are added to car. And also, if we, for example, change the wheel size on a sports car, then we'd also have to change the sports car manual class to correspond to this changed wheel diameter. So the above solutions here are ugly and difficult to maintain. So let's now introduce the builder pattern to solve these issues. So here is the UML solution for the builder pattern. So we can see here we have a builder interface with a few methods. So we have here set car type, set seats, and we'll also have the rest of the methods such as set engine, set dashboard, etc. So these methods kind of represent the steps involved in building either a car or a manual. And then we have the sort of concrete builder classes. So we have one for building a car and one for building a manual. And you can see here in this car builder that we store a reference or a field of a car object, and then we use these methods, so such as set car type, we'll set the car type on this car object, and then we have set seats, and we'll also implement all the other methods that we need from this builder interface. And then finally at the end we have a get car method which will just return this built up car. And then we have the same thing for manuals, where we have a manual field. So in this manual builder we're going to be building up a manual using these methods that we have implemented from this builder interface. And then again finally we have a sort of getter method where we can return this built up manual object. So a car and its manual are two different objects that don't share a common interface. However, they can be constructed using the same steps, as each specific component in a car needs to be documented by its manual. So by abstracting the object creation logic into builder classes, we can create cars and manuals by only specifying the steps required to build that specific car or manual. So let's take a look at how we can implement this in code. So let's now solve this problem using the builder pattern. So first of all, let's create or recreate our car class. So you can see beforehand that the way we were creating cars is that we pass all of these values into the constructor. Now what I'm going to do is I'm just going to provide, I'm going to change these from fields to C# properties just for convenience. And you don't have to do this. We could still have car exactly the same as we had it beforehand. As we had it in here, we could pass all of the fields into the constructor. However, I'm now just going to build up a car by setting the properties with getters and setters. So let's now import these components. And then let's create our manual in the same way. So we're going to move away from passing the values into the constructor, and we're just going to use properties to set the fields within the builder classes that we are going to create. So let's create a manual class. And I'm just going to copy and paste this in because it's pretty much what we had before, but we're now using C# properties rather than setting the values in the constructor as we did before. So we just need to import these components. So we're going to use this namespace. Okay, so now we can build our builder interface that will contain all of the possible steps for building a car or a manual. So let's call this iBuilder. And in here we're going to have some methods. So first of all, I'm going to provide a reset method, and this is going to essentially, in our concrete builders, it's going to reset the kind of object field. So for example, if we have a car builder, the car builder has a field of car, and it builds up that car with the methods that we provide in here. And the reset method is basically just going to kind of reset that car object to a brand new object. So this is just a common method that is often included in the builder pattern, and it'll become more clear when we actually use this method. So next up, I am going to create a set car type method, and this is going to return an iBuilder. And the reason we're actually returning a builder from this set car type is because it will allow us to chain methods onto each other when we are creating a car. So again, hang on, this will become much more clear if you don't understand when we actually use this solution. So I'm just going to copy and paste in the other methods now to save some time, because it's pretty obvious what we are doing. So we're just adding in the other methods. So as you can see, we have all the steps that we need here to build a car or manual. So we can set the engine, we can set the wheels, we can set the dashboard and pass a dashboard in, etc. So now let's build the concrete builders. So first of all, let's create the car builder. And this is going to implement the iBuilder or the builder interface. So let's implement that interface. So let's see, so the car builder, if you remember, needs to store a field of a car, of type car. So let's go ahead and do that. And then in the constructor, we can call the reset method. Okay, so essentially, whenever we create a new car builder object, we are going to set this car equal to a new blank car object, a fresh car object. So to do that, we can first of all create a constructor, and we don't need to pass anything to this constructor. We just want to call the reset method, and inside of the reset method I'm actually going to move this up so it's a little bit more clear. We're just going to set the car field equal to a new car. Okay, so next up, let's implement some of these methods. So first of all, let's implement the set car type method. So where is that? Okay, so in here we pass the car type that we want to set the car to, and so the way we can do this is we can just call car.type equals type. Okay, and then remember we need to return an iBuilder at the end of this method, so we can just return this builder, because this is a car builder, which is a builder, because we're implementing the builder interface. And again, this will become clear why we're doing this shortly. So what I'm going to do is I'm just going to copy and paste the rest of these methods in, because it's again very obvious and a little bit laborious. So let me just copy and paste those in. So I'm just going to copy and paste the whole class in actually. Okay, so that should be everything we need. So let's just go through what we've done here. So again, we have a car object which we are setting to a blank object upon the builder's construction. We then have our methods, which are the steps involved in building a car. So here we can set the car type, we can set the dashboard, and we pass the dashboard in. We can set an engine, the GPS navigator, the seats is convertible, set wheels, and then finally we have our get car method, which will return the car at the end. And you can see here that we store the car in a variable, and then we call reset, so that we are essentially resetting our car as a new car object once we get the car. And this isn't necessary in the builder pattern, but it's just something that's commonly done. So it's kind of like an optional step, whether you reset the object when you get the object, or whether you just leave it as it is. Okay, and then maybe call reset from the client. So that's just an implementation option, I guess. So next up, let's build the car manual builder class. And we need to implement the builder interface. Okay, so what I'm going to do again is I'm just going to copy and paste these methods in to save us some time. So it's going to be exactly the same as what we have in our car builder, because it's implementing the builder interface. The only difference is that we are storing reference to a manual rather than a car. That's the only difference that we have here, and we just need to import or use this namespace for the components folder. Okay, so that's everything that we need to do here, and as you can see, it's exactly the same as what we have before. So if I just go through one method, we have the set car type method here, where we pass the car type, and then we call manual.type, which is a property on this manual object. We set the type and return this car manual builder, so that we can chain the methods onto each other whenever we are building a car manual. And again, that will become clear when we use these classes. And finally, we have our getManual method, which stores the manual in a new variable, calls reset to reset the manual field to a new manual, so a new blank manual, and then we return the manual. Okay, so that's everything that we need to do here. So let's take a look now how we would use this class in the client. So I'm actually just going to, let's comment this out. And let's go down here, and first let's create a car builder. Okay, so then we need to import this. Okay, so next up, let's actually build a car using the car builder. So we can say car builder dot set car type, and then we can set the car type to car type dot sports. So we're going to build a sports car again, exactly the same as we did beforehand. We can then set the number of seats. Let's see, set seats. Do we not have a set seats method here? Maybe we're missing a method. Okay, so it looks like we didn't actually include our set seats method in here, so let's add that in. And we're going to set it to, okay, so we pass in an integer for the number of seats, and then we actually need to add this method into our car and car manual builders. So let's just come down here and we'll say public iBuilder set seats, and then we'll say int seats, and we'll set the seats and return the builder. Okay, so let's see, what have we done wrong here? Car builder already defined set seats with the same okay, so we've actually provided this method already. Okay, so we didn't have it in the builder interface, but we did have it in the builder itself, the concrete builders. Okay, so we just needed to add it here. Okay, so let's go back into our client, and we can now set seats, hopefully. There we go. So this is going to have 2 seats, and we can set the engine to a new engine, and let's see, set dashboard to a new dashboard. Let's see, what do we need to provide here? Has rev counter, we'll say true. And let's see, so we've got a dashboard, set the wheels, and it will have 4 wheels. Actually, we need to provide the wheels components, and then we set the diameter in inches to 20, and that, I believe, is everything we need to do to create a sports car. So now we should be able to get the sports car. So we can say car builder dot get car, and let's see, we then should be able to set the fuel on the car. Sports car dot set, maybe it's fuel, and we'll say 100. Okay, so let's run that to make sure that we've got no issues here. And I believe that's all okay. So let's now create our manual builder for a sports car. So here you can see we're using the car manual builder, and then we are calling all of the same methods as we did previously, and then we get the sports car manual by calling manual builder.getManual, and then we are logging the printed manual to the screen. So let's see if that logs correctly. Okay, so that all looks good. So this is a nicer solution, as we now only need to specify the car or manual properties that we need. For example, we don't need to specify if the car is convertible like we did beforehand when we had to provide all of the data in the constructor of a car or a manual when we were creating those objects. And also notice how we can conveniently chain methods onto each other, because we are actually returning the current object from each method call. So if we check set seats, you can see in this interface we have to return the builder, which means that we can keep on chaining these methods onto each other. And we could also return void from each of these methods and then call each method line by line. So for example, carBuilder.setCarType, and then we'd say carBuilder.setSeats. But it's just nice and convenient to be able to chain these methods onto each other. So the problem with this solution here is that we still have to specify a large number of fields when creating cars and manuals. And also, because Car Builder and Car Manual Builder both implement the same iBuilder or builder interface, we can now use polymorphism to create cars and manuals, as producing a manual for a specific type of car, for example a sports car, requires the exact same steps. So for example, if a car has a GPS, then it also needs to be documented in the manual. So we can implement this using a director class, which I will show you next. So you can see here we still have the exact same builder pattern that we had beforehand. We can see we have the builder interface and then our concrete builders, which implement the builder interface. But we've now added this director class to our pattern, and you can see this director class has 2 methods here, one for constructing sports cars and one for constructing SUVs. And you can see that we pass the builder that we want to use into each of these methods. So for example, if we wanted to construct a sports car, this method would contain all of the steps in this sequence for producing a sports car. And if we wanted to produce a sports car sports car, then we would pass the car builder. If we wanted to produce a sports car manual, then we would pass the manual builder. And because the steps for producing a sports car and a sports car manual are the same, we can just pass the builder and it will construct the sports car or sports car manual correctly. And we could also do the same for different types of cars, different such as SUV or any other type of car. So we can see here that we have this dependency relationship between the director and the builder, and that's because we're passing the builder into as an argument into each of these methods. So the director class is actually optional in the builder pattern, as the build steps can be specified in the client, and that's what we did here. But it's often useful for putting common construction routines into this director class so that they can be easily reused throughout your application. So let's now take a look at the Gang of 4 representation of the builder pattern. So you can see here we have our director class, which has methods that contain commonly used routines, and we can pass the builder that we want to use into each of these methods. We then have our builder interface with a reset method for resetting the object that we are constructing to a new object. And then we have our build steps. We then have our concrete builders, which implement the builder interface, and each concrete builder needs some sort of method for getting the result of the builder after the product has been built. So note that above we are passing a builder to each method in the director class, but it's also fine to store a reference to a builder and then use methods for changing the builder at runtime, like so. So here you can see we have a different way of implementing the director class. So rather than passing the builder to each of the methods, we can actually pass the builder to the director's constructor when we are creating the director object, and then we provide a method for changing the builder. So for example, let's say we first of all want to build a sports car. We pass the car builder, then we call construct sports car, and then if we wanted to produce a sports car manual, we can call the change builder, pass the manual builder, and then construct the sports car again, and this time it will produce a sports car manual. So as you can see, both ways of implementing the director class are totally fine. I just wanted to show you a couple of different ways of implementing this class. So let's now build the director class in code. So let's create a new class called director. And we're going to give this class two methods, one for constructing a sports car and one for constructing an SUV. So first of all, let's create the construct sports car method. And we need to pass the builder to the method. And then we can call the builder, we can call all of the build steps on this builder. So what I'm going to do is I'm just going to copy them from our client code that we have here, and this needs to be builder, and we also need to import our components. Okay, so I think everything should be okay here. Okay, I'm just going to move this in a little bit. Okay, so that should be okay. So let's now also create a method for constructing an SUV. And again, we pass the builder. And then I'm just going to copy and paste this code in that I have here. So this time I've actually called the steps on the methods on the builder line by line, so just so you can see the difference between chaining the methods and sort of calling them one by one. So just two different ways to do it there. Personally, I like chaining. It's a little bit more convenient and we don't have to keep on writing the builder over and over again, but both ways of doing things are totally fine. So note that we don't actually return the product, so the product being either a car or a manual, from this director from each method within this director. And that's because each product is returned from its respective concrete builder. And this is because car and manual objects don't share a common interface. So let's now go into the client and see how we can use the director class. So I think what I'm going to do is I'm going to comment out all of this code here. And let's first of all create our car builder. And then let's create our director class. And then let's create a sports car, so we can call director.construct sports car, and then we want to build a car, so we pass the car builder, and then we can say sports car is going to be equal to our car builder dot get sports car. Actually, sorry, it should just be get car. Okay, so then we have our sports car, and let's just check here. So that should be sports car. Then we can call sports car dot fuel and put it equal to 100. Okay, so that's pretty nice. So let's also now construct an SUV. So we can say director dot construct SUV, and we can pass the car builder, and then we can get our SUV. Let's say SUV car equals car builder dot get car. Okay, and then we can set the fuel to, let's see, dot fuel equals 40. Okay, so let's now produce some manuals for these cars. So we can first of all create a manual builder, and this should be car manual builder. And then we can call director.construct sports car, so just the same as we did here, but instead of passing the car builder, we now pass the manual builder, so that we build a sports car manual. So then we can actually get our sports car manual, so we can say sports car manual is equal to manual builder.get manual. Okay, and then we can print the manual to the console. Okay, so you can see that VS Code is giving us no errors here, because here we are returning a car object which has a fuel property, and here we are returning a manual object which has this print method for printing out the manual. Okay, and we can also do the same for an SUV, so I'm just going to copy this in to save a little bit of time here. So you can see that we are also constructing a manual for SUV. So let's run this program to make sure everything is working correctly. So let's see what we have here. So we have, first of all, we have our sports car manual, so we can see the car type, sports, the seats, the diameter of the wheels, etc., which is all correct. And then we have our SUV with 5 seats, a slightly smaller diameter of wheel, etc., etc. So this is all working as it should be. So here we have used the builder pattern to reuse the same object construction code or build steps to build different kinds of products, so cars and their corresponding manuals. So other creational patterns focus on producing objects that share a common interface, but the builder pattern differs in that it can construct objects of different types, providing that they share a common set of build steps.